Thanks everybody for having me here. This is a really impressive campus. I've not been here before. This is a pretty cool place. And the energy in this facility is pretty cool too. I had a good lunch and everybody was smiling, which is not always the case on a corporate campus. So I commend you for that. On a Friday, yeah. So thanks for taking time post-lunch to hear this. I'm going to save time for questions at the end. I promise this will only take 3 hours. So I will end on time. My name is Justin Smith. I work for Pivotal. I work on security. I'm part of a team that focuses on security at Pivotal. I have been in cloud security specifically for about 11-ish, 12-ish years, depending on how you count. I was on the founding team of a little thing called Azure Active Directory at Microsoft. I was one of the first 4 people on that team. I was an early contributor to what's now called OAuth 2. And then I was the product lead for accounts.google.com. So I went to Google, moved down to California, and did that for a while. It's a lot of fun. That experience has been very formative in how I think about security, how I think about distributed computing, and other things like that. And so this is a distillation of how I think about security plus trends in the last couple of years that are pretty clear to me. And so I'm going to try to pepper this with stories as well as concrete things that you might be able to think about and actually put into action as well. Anybody see today in the news that Sing Health just leaked like 1.5 million records of citizen data, including the prescription information on the Prime Minister of Singapore? Right? This kind of stuff happens at a really fast cadence. And you know, there's been talk in the news today of the blinking red lights. All the lights are blinking, you know, internationally. For me, the lights have been blinking for a long time. And the tempo of security operations that we're exposed to and that we have inside of Pivotal is going up and to the right, right? And so the question for me is really, how does an organization deal with an uptick in tempo and actually make more scalable, smarter decisions over time, right? And I think that's a real challenge. And I don't think there's any technology that's a magic pill. I don't think there's any framework that's a magic pill. I don't think there's any process that becomes magic. I think you have to look at this as a holistic challenge. So we're going to focus this talk really on security in the enterprise, specifically in the data center. We're not going to be talking about mobile device management. We're not going to be talking about authentication technology, multi-factor auth, things like that. This is really what goes on inside the data center, right? Just to focus that. And I'm going to tell you a story. So, you know, speed limits on the interstate are anywhere from 55 to 70, maybe in places in Wyoming and Montana. They're unlimited, I don't know, right? But, you know, when you look at these signs, these are really policy statements that we try to enforce, and collectively, it's up to us that have driver's licenses and vehicles to, you know, comply, right? Now, if you think about it, in the United States, I think last year there were about 40,000 deaths on the highway, right? That's a lot. That's a big number. And a lot of that is actually attributed to doing stupid stuff on the road, including speeding. So as we're driving home today or we're in a car this weekend, if we're going beyond the speed limit, what we're really doing is making a moral calculation, right? We're either betting with our own lives or the lives of people on the road around us and saying it's going to be okay this time. And we're making a probabilistic decision, right? Now think about it. Not obeying the speed limit actually is a moral calculation that we're doing implicitly. So how do we fix this problem? Well, you can put more police on the street, right? There's a lot of statements from, you know, by Hobbes and classical philosophers about what it means to meet a civilization with more force. You end up getting more force back, right? So one approach to this is to do more enforcement of the policy. Does this kind of ring true in enterprise security? You put more enforcement out on the street, it doesn't tend to go well. Well, manufacturers could also solve this problem of speeding if you see it as a problem you want to solve. You could say cars aren't ever going to go past the speed limit, right? But nobody would buy that car because the psychology of speeding is, I want other people to obey the speed limit, but I want to have the ability to exceed the speed limit because I'm safer than everybody else, right? Well, what's the answer? I don't really know what the answer is, but there's an amount of technology that might actually prove interesting here. The rule that says you can't go beyond 55 miles an hour really applies when you've got human drivers. Let's say in a fantasy world, you have automated cars that are self-driving. Here you've got LeBron chilling in the back of a car sort of with a nervous look on his face that's driving itself. If you have this world with a flood of technology in it, it's possible that you don't even need the speed limit anymore, right? So there's a level of technology in play here that could actually solve what was otherwise a deadlocked problem, right? So it's possible in an autonomous driving world to be safer, fewer deaths, and maybe even exceed the speed limit. To me, this looks a lot like security in the enterprise, right? Metaphors are all imperfect. This one's pretty imperfect right away. But to me, when I look at enterprise security, there's a lot of similar problems, right? Here's kind of the picture that I see across FinServ, across government, across the intelligence community, across healthcare, retail, other verticals, right, that we interact with pretty extensively. Technology tends to be project-based. That's how projects are funded. And so you have, over time, lots of projects that have different types of infrastructure, which means your security controls are pretty different from project to project. You might have some WebSphere, you might have some stuff that's done on top of Tomcat. You've got a lot of different technologies in play. And teams get to make those types of decisions, and you get big variability. You have slow enforcement. In other words, you have to do time-based or milestone-based checks to make sure that you're in compliant before you go to prod. You have a very waterfall-driven model for enforcement. And enforcement gets stuck on a local maximum, right? You can never really figure out how to truly go faster other than adding more people into your compliance teams, and that tends to not work too well. There's mass casualties. You may know that you have 1,000 servers that haven't been patched in 90 days, but you're not really sure what to do with it because you're busy putting out other fires. So you have a mass casualty situation, and then quite frankly, this is what's really hard to measure. It's intractable. Much like the speed limit problem, it is completely intractable, and you will find people whose job it is to patch servers, and they look like they're going to work in a salt mine every day, right? It is a thankless, terrible, very difficult kind of a job with low morale. There's no clear answer, and it looks like it's just a mundane, never-ending task. Does this sound familiar to anybody? Right? Now, I'll tell you a little story from my own career that was super formative before you get into the real meat of this. When I was at Microsoft, we were trying to do something in, as a service that was a developer tool. And there were 4 of us that really didn't know much of what we were doing, and we didn't have any cloud to deploy to. We had to build racks and things like that. And the team eventually grew to be about 70 or 80 people. I don't exactly remember how big it was by the time I left. But we could push code about every 2 months, and we were super proud of ourselves when we were able to push that fast. It was revolutionary at Microsoft. This is circa 2008, 2009. And it never worked. It was a goat rodeo every time we tried to deploy, right? We'd do it on the weekends. Execs would bring in ice cream sandwiches, and it was a big deal. Now, since then, probably because I left Microsoft, they got a lot better, right? And they do this in a world-class way now, right? I mean, I think I have the utmost respect for Microsoft as a company, particularly on the cloud side. Now, so take pushing code every 2 months and having it not go well, and then I go traipsing over to Google. My team shrank by a factor of 10. It was about 8 of us for the OAuth 2 side of accounts.google.com. And the load on that service went up by 1,000-fold. So half the smartphones in the world depended on that thing. Or every Google API depended on that thing. A lot of session validation required that thing to be available. And it was 8 people. And I'm like, the ego side of me wanted to say, wow, they do it every week. They push code every week. And they're doing this massive geo-distributed problem, and it's always available. This is amazing. These people are so smart. I wanted to think that I had arrived finally with the nirvana set of engineers that could do anything. And guess what? They were mortal, just like they were at Microsoft. There's a huge difference, though. What do you think the difference was between these 2 extremes? Anybody had to guess? You can shout it out. It's not that they're in California and there was free food and free healthcare, right? What was really different was the platform. The responsibilities that that team of 8 had was very different than the responsibility of the 80 people. The 80 people had to deal with storage, had to deal with logging, log aggregation, all the dashboards, all the alerting, running the server, doing the deployments, doing all the scanning, all of this stuff, network flips, right? Making sure that all that stuff worked. Whereas this team of 8 people was using test harnesses, basically pipelines at the time, and all of these dashboards and infrastructure that had been burned in by search and AdWords, right? So it was basically you're building a Java app. The responsibility matrix was very, very different, right? When that responsibility matrix gets smaller and you get more capability out of a platform, a team of 8 can change the world, right? And that was a very formative lesson for me. If you think back to the goofy driving metaphor, if the operator of the vehicle, instead of just riding in the vehicle, has to deal with speed limits, avoiding obstacles, and doing all these other things, you're going to get imperfect results. When you move that into automated technology, you stand the chance of changing the dynamic, right? And that has been very formative for me. What we do at Pivotal is give you a platform that changes that responsibility matrix in a pretty dramatic way. And that's actually why I went to Pivotal, because I think we do stand a chance to change the enterprise security dynamic. And so, instead of talking about what we're trying to avoid exclusively, right, seeing sort of the mass casualty situation of enterprise security, what is it that you actually want? Well, you really want the combination of speed and security. You want to be able to go fast while also increasing safety. That's kind of the holy grail. Now, the question is, how do you get there from here, right? That's the gazillion-dollar question. How do I take whatever situation I'm in today and get to a place where I'm going fast and I'm being safer, right? That's the hard part. And again, this is not about just introducing technology. This is not just about changing process. It's a holistic view. And so I'm really not going to be talking about the features or capabilities inside a Pivotal platform at all, right? Because I think you have to look at the whole picture. And so really, you want some type of a framework, some sort of a mode of thinking that's going to inform technology decisions and process decisions and things like that. And so in the DevOps world, I'm not really a big fan of that term, but it's here to stay, or at least for a while. There's this initialism called calm. Now, I don't know about you guys, most security teams that I come across don't give off this energy of being calm, right? But I really like it to apply this DevOps initialism to security. So it's how do you think about culture, automation, lean controls, and metrics? If you use this as a way to kind of structure your thinking, you can pretty quickly see how you can get a transformative situation in security across the enterprise, right? Now I'm going to walk through some examples of what this means in each one of these dynamics, and I'm going to give you some stories that are applicable directly from Pivotal and other places that we've worked with. Let's start with just kind of the types of people and personas that work in security. I found it extremely hard to go into the hiring market, to go into the job market, and find people that have 10, 15, 20 years of experience in enterprise security or maybe reverse engineering malware or something like that. Finding that type of person that isn't antisocial and aggressive. So if you're on the job market with a lot of security experience, there's probably a reason. There can be a reason. I'm not saying in every situation. But we've made some really bad hiring decisions that have caused me huge HR headaches, right? The people that tend to be attracted to security are a little bit, I'm weird. Now you can ask my ex-wives, I'm really weird, friends, family, that kind of thing. We tend to be weird, and it's hard to find us on the job market, right? And so you got to think about the staffing requirements. So the big moment for me really at Pivotal is I need to stop trying to hire the people that I think have the ideal skill set. I I need to keep those feelers out there. Every once in a while you get lucky, but I need to figure out how to bring it in from what we already have, right? So first you've got to be a fit in the Pivotal culture. First you've got to pass the engineering requirements and things like that, and then we'll talk about, security specificity. But this is where I had to come down out of an ivory tower pretty quickly, right? A lot of the tasks that a security team has today are not really domain heavy in security. I'm not saying all of them are generalist tasks, but a lot of what you'll find in security requirements of an organization are pretty much generalist tasks, right? Particularly around automation and otherwise. So first, when you think about staffing this, you don't really have to go out and find somebody with a lot of experience in security. A lot of the work can be done by generalists. It's a huge, for me, that was a big aha moment, right? And those people have to be able to code, right? So coding is an absolute requirement for us. And the idea is we have to be able to build tools that other people want to use inside of Pivotal. So we have about 70 to 80, depending on how you count, different component teams inside of Pivotal. And what we call the security team, there's a few different security teams, is the security enablement team. Now, I hate the word enable because it describes sort of a weird family dynamic that's a little destructive, but maybe empowerment would be a better term, but we didn't think of that at the time. So the enablement team is really about building tools and services that those other component teams want to use. And if you go look at a big bank, for example, one of our big banking clients actually names their security team the security enablement team too. And so this is an idea that works even at big organizations, not just product companies, right? So if you're thinking about building tools that you want to use, other groups want to use, you've got to have empathy for developers and you've got to have empathy for operations, right? Those are absolutely must-haves. And then I'll say the last thing. The most dangerous people writing code are those that are probably my generation, you graduates in the 90s, right, from software engineering. When I see people come a year or two out of the better schools, now computer science schools, their knowledge of cybersecurity is well beyond what I had anything in school, right? I can take somebody that's a year or two out of school and they can most often explain to me what a cross-site scripting attack is, cross-site request forgery, confused deputy types of attacks. And so I think schools are actually producing better caliber of security-aware people, and so definitely tap into people that are newer. And then the last thing I'll say about this is cybersecurity is just cool. And so we're willing to attract anyone that wants to learn more about cybersecurity in practice because it's absolutely front and center in our national consciousness. It's in the news every day. It impacts our elections. It impacts a lot of what we do, right? And so we use that to try to build up our capability. The next thing is we build a model inside of Pivotal to try to change culture, where you can do a rotation on the security team for 2 to 3 months, right? So we got acceptance from up on high that as we're engaging with different component teams, if they show an interest or predilection to kind of want to learn more, they can do a rotation with us, and we'll keep all their comp and everything squared away. And so the value of doing these types of rotations is it helps us build tight relationships across the whole company. 800 or 1,000 people, there's over time a high degree of cycling through the security team so that people are writing better code. Because we found training classes to not be all that valuable, right? And so when somebody goes and pairs with us for 3 months or 6 months, one, they might want to stay, which is awesome. Two, when they go back, they're not going to have a 1,000-yard stare, but they're maybe going to have a 500-yard stare. Like, I think I'm kind of a ruined individual because when I look at a distributed system, all I can see is all the places it'll break, right? And I look at how it can be attacked. That's just how I've been, deformed over time. And so I think if you're exposed to that, it can be actually healthy when you go back into your component team, right? We do lunch and learns, right? Where we say, here's something that happened, here's something that we learned from, here, have some free food, and we'll celebrate how much better we are now. And then we do retros and stories and things like that. There's more that I'll talk about here in just a second. But if you study reputation too and culture, there's two types of reputation, or at least two. One is dominance, and the other one's prestige, right? And security teams sometimes have a culture where they're used to throwing rocks from the ivory tower and telling people not to do it that way. Oh, look how silly that decision is. You can't do that. No, 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 no. That's a culture of dominance. Culture of prestige is very different, where you try to engage with the component teams, and I think this is a much more useful model. And we had to play a couple of tricks here. Does anybody like to do threat modeling? It's a standard control. This is like 2-3 weird people in the audience. That's cool. We tried to institute, and we've seen this at a few banks too, sort of broad threat modeling as part of the basic of any group that's going to build software. And so this means, can you actually label the types of threats to your component and how you're going to mitigate them, right? The problem is nobody wants to do it because of security fatigue. It looks like a checklist kind of activity, right? And so in the Pivotal culture, we have baked into our common layer of cultural norms, we have devout devotion to the rituals of IPM and retro and inception. So at the beginning of the week, the team gets together and they prioritize their stories for the week. At the end of the week, everybody gets together and says, how'd it go? You do a retro. At the beginning of a big slug of feature work, you do an inception with the product owners, engineering team, and others to say, is this what we're going to build? How's it going to look? That is baked into the Pivotal culture. So we rebranded threat modeling to be something called security inception. And so what we do across our component teams is we sit together, and it forces the security organization to be on their A game. We bring them in a room for 8 hours, and we start with something similar to, who's your attacker? And the hope is, at the end of that 8 hours, we have a set of stories that that team will want to, of their own volition, go out and prioritize to go complete. And that hardens their component even more. That's not us saying, throwing a rock, you've got to do these hardening steps before you release. It's trying to create a different dynamic, and the results for us have been dramatic, right? So building this culture of prestige has been something that we've been working on, and I'll tell you 2 other side effects of this. One of them is we find people that are interested in security and want to do a rotation. So you'll find the people that find this stuff really cool, and they'll want to come join the security team for a period of time. Now, granted, anchors don't really appreciate it when you go and poach their people, but it's for a good cause, right? And so it's okay. But at the same time, we also have the ability to say we're going to block shipping of anything, right? And so we reserve the use of the big stick unless it's absolutely necessary. So if you look at this stuff kind of in totality, right, and these are things that we have very directly implemented at Pivotal, and several of our customers have implemented too, you see that over time, you start to turn the ship, and you start to see a cultural change in security. Because at the end of the day, what really matters is, are the people that are writing code doing the right thing? Make sense? Any questions, comments, or personal attacks before we go into the automation, kind of another part of it, the next phase of this?
8 hours sounds like a long time.
Oh, it is, yeah. I mean, if it's not 8 hours, if it's like 6, then all right, cool. But what it forces us to do is, like, you can't pull out your phone. You got to actually pay attention, right? And so we block that day. And we're not talking about bringing 30 people into a room. It's usually a 2-pizza size group. Sometimes it's a little bit bigger. But that's enough, and you can get an awful lot done if you're not looking at your phone and not doing email and all the other things, right? Yeah.
Chris, you talked about your security team. Can you give any smaller examples of what they work on?
Yeah, so the question is, what does a security enablement team work on? It's automation tooling. So the next letter is A for automation. There's a lot of scanning that you've got to do in a pipeline And I don't know if it's just our use of scanning technology, but we have found it to be horribly a pain in the butt, right? And there's probably, somebody might watch this that works for a scanning vendor and says, you haven't used our tool. We've tried them all, right? But there's problems with it, right? And I mean, I have friends with VCs that invested in, so it's just, I don't know why, but it just is. So if you don't have the knobs adjusted just right, you get false positives. And when you get false positives, it creates a lot of noise. The really scary thing is when you got knobs turned the other way, you get false negatives, and it's like, oh my God, what, that's the worst type of error. And so you're walking this knife edge. So we've spent a tremendous amount of resources on getting scanning technology to be reliable that a team can pay attention to. And it was impossible for us to say, hey, a component team is going to go take on that work. We had to have a central team that could do that, right? And so there's a lot of scanning technology. And now this takes a few different forms. There's vulnerability scanning. There's injection scanning, things like, are you vulnerable to a cross-site scripting attack? But then it's also stuff like, did you leak a credential in a log file, right? So, credential leakage is one of these things that's really problematic. And so what I mean is if a password or a key or an access token or even an IP address, that's, sensitive information, if that ends up in a log file and sent off into some aggregation service, chances are it doesn't have the same access controls around it that you did in the production environment, and this can be disastrous. So the challenge for us has been, how do we, in addition to making sure everybody knows the right thing to do, how do we search log files for arbitrary types of credentials? It's a really hard problem, right? Regular expressions don't get you there, by the way. That's, there's no way to write a regular expression that's strong enough to get all that. Same thing with checking into GitHub. So we do a lot of open source contributions. And oh my God, if somebody happens to check in a credential there, it doesn't take 30 minutes for the bad guys to get it and then do something with it. It's quite remarkable. So the bad guys have the ability to somehow search GitHub and find credentials reliably. I don't know how. But we've had to come up with our own tech for doing that. Those are some of the examples. But we also have parts of our platform that are very security specific, like our credential vault called CredHub. But that's not the enablement team. That actually started there, and then it became its own product team. Automation. This is where you really get huge payoff. That's how you get your 100 or 1000x change. And when you think about security, it's hard to draw the boundary around automation and security. Scanning is a big area of investment, and I like to think about this as a tiered situation. So you want teams to be building pipelines that do scanning early in their process, so scans don't get handed over to the security team halfway, right before you want to go to production. It's very hard to manage 100 or 1,000 different teams that have their own pipelines and their own technology that they're trying to bring to bear, but you want them to be able to use the scanning technology. I suggest you put it also on ingestion into your platform with the same knobs and bells and whistles that a team should be using. So if you have a tiered approach to scanning, do it in your CI/CD system, but you're also going to do it when you deploy. So the idea is you're not going to get through the gateway when you push to prod if you haven't done it in your CI/CD system. It incentivizes the right types of behavior. This is a big area of investment. Anybody know what a service broker is? Yeah. So this is, I think Pivotal's probably biggest contribution to the cloud. This even, surpasses Cloud Foundry. Service broker is a 5-web method or 5-function web service that is how you connect a containerized application, whether it be Cloud Foundry, Kubernetes, or a function type model, to a legacy system or a service like a relational database. And so it's a way for provisioning access to a service and deprovisioning access to a service. This is automated provisioning is how you get out of doing stuff in spreadsheets for passing passwords around and network access controls. So it gives you a place for centering your automation and policy enforcement for binding apps to legacy that runs your business today. It's a really good muscle to have. And lastly, app scorecards. Security teams care about awareness, focus, and flexibility. Are they aware of what's going on? Can they focus on where they think the biggest risks are? And can they change as the risk profile changes? It's very hard to get transparency into an app. How secure is it? Are all the controls in the right place? Have they done the right thing? If you have a scorecarding system, you can get a couple of interns to build it, put a security.yaml file in your repos, and you can start to feed this stuff back to a central team. It's very easy to do. I don't know of a turnkey way to do this, but this is how you start to get organizations to participate into opting into controls. Now, has anybody heard of lean value stream mapping, or sort of the lean startup, and how you get teams to move faster? Well, guess what? I think some of the same ideas apply to security controls. So there's a model for thinking about mitigations called ATTACK. I didn't come up with this. It's a MITRE thing. Adversarial tactics, techniques, and common knowledge, right? Fantastic. And so if you think about how something can break and what an attacker is likely to do on your distributed system, the mitigations that you have in place, your kill chain, in other words, should actually inform what controls you have in place. And so you can do a value stream mapping analysis on the controls that you have to actually see if they're useful. And if you can't tie them back to an attack, then chances are it needs to be disposed of. Controls, security controls, us in the security space tend to think about controls as this everlasting, eternal thing, and they're not. We need to think of controls as something that has an expiration date, or a do not use past date. Leverage everything you can in your platform. I don't care what it is. Let me give you an example. Does anybody like to work on single sign-on authentication technology? Is it really cool to parse a SAML token? Anybody even know what I'm, right? Is that fun? Is that cool? Yeah? Really awesome stuff. If you haven't tried it, go Google it. Go look at a SAML token. Look at all the little fields in the XML. It's really cool. That's the technology that a lot of your ping federate ADFS will use when dealing with enterprise login to web apps. And it's an embarrassment, right? You really don't want your developers having to learn all that stuff. If your platform can do that for you, for the love of God, take it out of control of the developer and put it in control of the platform. There's a lot of different ways that can happen with single sign-on service. You can do gateways. There's all kinds of technology there. But if you can get that out of the hands of the developer, they'll actually appreciate it, right? Because nobody wants to mess with that stuff. Logging, log forwarding. Nobody wants to muck with all the settings that it takes to forward logs properly into an aggregation service. That should all just be done by default. And then the last one is compliance as code. When you look at what's going on in operations and how you manage a big platform, almost everything gets checked into GitHub. Configurations get checked into GitHub. I was just looking at some dashboards today about what it means to take a patch from a vendor and then push that patch into a pipeline for it to get pushed into the data center. You can do an awful lot right now with source repositories and automation, and I think compliance is something else that looks like code. Now, it might just be YAML files, right? But you want to be getting in a mode where your security controls end up getting checked into some repository so that you can see a strong history of it back and forth over time. So it really matters. And there's a super cool project called opencontrol.org that's really driven by the intelligence community and what it means to make a change to, say, satellite image processing for the NGA, right? Which is an organization most people have never heard of, right? But you don't want developers in those communities just making wanton changes to systems, because bad things can happen. And so this is a way for them to build their system security plan that keeps up with the system and the rate of change they want to make. And then lastly, our metrics. I don't know how an organization functions if there aren't metrics that describe the health of how things are going, right? It's very hard to get metrics around a software development organization, right? Because it's really dependent on the people. But I'm a strong believer in using data and metrics to sort of be an approximation of what's going on in the real world. Now, I say all of this stuff with a strong caveat of never confuse the map for the terrain, right? Because as soon as your organization starts to look at some KPIs, they get gamed immediately, right? Sales organizations are notorious for this with compensation plans. But there's usual suspects that I think still apply in a modern world for metrics. And that's, how many vulnerabilities do you have? What's the average severity? What's the length of time that thing stays in there? But I also like to look at some other, what we call usual suspects. How many apps are running on a modern platform versus something that's more hand-rolled? That's very security specific to me. I care about that because I believe modern platforms tend to be more secure than, state-of-the-art 5 years ago, right? And that'll probably always be the case. How many users, how many administrative users, how many developer users, how many pipelines do you have that are actually pushing apps? What security agents do you have in play? Things like that just really make sense. But for me, if you're going to start looking at operational stuff, like SOC events, things like that, you got to also think about false positives. So the scanning tech, right? If you're doing post-processing on the results of a scanner, please, start to track error rates, right? Flapping tests are notoriously bad. You want to start to track that information because it's really about team happiness too, but also team efficiency. And then this last one, since you heard a talk earlier on the 3 Rs, the repair, repave, and rotate concept for platforms is really about how do you create an ephemeral infrastructure that's harder to attack. Infrastructure that sits around for a while in a static state is really easy, relatively easy to attack. If you look at the indictment that came out last week, right, and you read through sort of the profile of the attack on the DNC, those attacks required the attacker to have time in the data center on servers so they could start to poke around. Imagine if you're sitting over there trying to attack an organization and after an hour your command and control disappears and you've got to do another infiltration. Right? That becomes a much harder target to attack than something that stays static. So the old model of security of saying you have something that you accredit and then you put monitoring agents to see when it goes stale or something goes wrong, that has proven to not work really well. And so new infrastructure, modern technologies, certainly like Pivotal, should be able to be rebuilt and patched almost continuously without any downtime to apps or the control plane, right? And so start to measure the lifetime or the age of your infrastructure with the assumption that the younger it is, the better off you're going to be, right? And so there's, I've written a paper on this and, its own separate talk. But this forces the right behavior. And you can do it for containers, you can do it for VMs, you can do it for clusters. Doesn't really matter, right? I recommend all 3. And then SOC events, right? So, if you look at any cyber organization, you'll have something like app and platform team, operations center, your security operations center, data protection, and then you will have something like identity and access management. Those tend to be the 4 disciplines. Sometimes you have it split up into fewer or more. Sometimes you have privacy as a separate one. SOC events really are the canary in the coal mine for how everything's behaving, right? And so your SOC events should be tracking attack profiles on your platform. In other words, let's say today you push a new platform into your data center. Your SOC might not actually understand what an attack looks like on that platform on day 1. So what I recommend is come up with 5 or 10 attack profiles so that your SOC, when you're looking at logs, they're not having to sprinkle the magic of machine learning over it. They can say, if this happens, ring the red phone. If then else statements are much more concrete than the fuzzy logic of machine learning. There's a time and a place for that, but if that number of attack profiles is 5 today, next quarter it should be 10, right? You want to see that number going up and to the right, because that shows maturity. And so I'm a strong believer in making sure that you've got that in your metric profile to look at, right? Now, I kind of zipped through the end part of this because I could sense that I was starting to run out of time. But between all of these, we've seen some examples of culture, how to invest in automation, how to think about leaning out your control structure, and then metrics to actually track how you're doing. And again, the point of all of this is how you get safer or more secure while also going faster. It's super easy for a security team to say, no, we're going to slow everything down, and we're going to walk along at a crawl. That doesn't do the business any good, and it doesn't do the security organization any favors either, right? So anyway, I'm sorry I didn't go into more of a sales-oriented presentation and talk about the virtues of our platform, but this is really how I think holistically about security. Cool. Well, thank you very much for your time here on a Friday afternoon. I hope everybody has a good weekend. Thank you very much.